Today we're going to take a look at sketching some of these parent functions, and we've learned some of these already, and then we're going to apply some of these transformations. So first one, we have a quadratic. And one of the things that we know about a quadratic relation, all right, I can sketch this as putting a 0, 1 and 1, 2 and 4, 3 and 9, and we know that that goes like that. All right, so we can plot this. All right, so I'm not saying that this is anything new, but we can sketch this parabola. Okay, nothing crazy. We're going to keep these points handy because we're going to do transformations for these down the road. Okay. Another parent function that we will look at is square root function. And the idea of a square root function is kind of like the inverse for a quadratic. Okay, so the idea of an inverse of a quadratic means that our vertex still started at 0, 0, our point 1, 1, and then if I did the next point, the square root of 4, that would get me 2. The square root of 9 got me 3. The square root of 16 would get me 4. All right, and what this is going to look like is taking that parabola that we have up there, and it's going to look like it's on its side. So I plot my 0, 0, 1, 1, 4, 2, 9, 3, 16, 4, and it would look something like this. And the reason why we don't have the second part of this bottom part here is we're only just looking at the positive part. Okay? So this is square root of x. All right, nothing crazy. Keep these points in line because we're going to use these to transfer them. All right, flip the page. The next one we're going to talk about is an absolute function. And this absolute value function looks like this. And the idea of this is it takes any value of x that we put in there and it spits out the positive results. And you're asking me, well, why is there a v? So let's look at this. 0, 0, 1, 2, negative 1, negative 2. And what happens here is the absolute value of 1, I'll make this look like a 1, is 1, so that's going to be that. The absolute value of 2 is 2, so nothing crazy about that. The absolute value of negative 1 is 1, so that's where this comes into play. And the absolute value of negative 2 is 2. So it's kind of like a straight line. We start off with a line here. There's my point, there's my point, there's my point. And it continues. And goes the other way. This is where the v comes into play. The v comes into play. So that takes any negative value and spits out the positive answer. Okay. So those are the three parent functions that we're going to use. Okay. The last lesson, we talked about how do we apply these transformations. Okay. So we're going to take a look at how do we apply them. So one way of doing it is creating two tables of values. One table of values represents the parent function. So if our parent function was this would be our starting table. And the other table applies the transformation made to the image. So what does each transformation make? Well, we know that already because that was what we did in the last lesson. So that was our vertical stretch. The K is my horizontal compression. Our C value told us the horizontal shift. So that was our left, right. And our vertical shift is our last one. So this is not new. We did this the last lesson. Okay, now we're going to apply it. All right, and at any time you need to pause to check your thinking. Please push pause and you can go through that. All right, so this is the meat and potatoes of the lesson. All right, so one thing that we're going to do is we're going to sketch the parent function. We're going to state the transformation, and then we're going to sketch by transforming those points. So if we can transform the points, we can transform the graph. So our parent function is y equals absolute value of x. So we know that 0, 1, 2, negative 1, negative 2, 0, 1, 2, 1, 2. This is what we're going to start with. Okay? So we're going to sketch that. All right? Nothing crazy. Okay? Now we're going to state the transformations. So we know that the 3 is a vertical shift, or vertical stretch. Of 3. That 2 is a horizontal compression. The 4 tells us to go right 4. And that negative 5 tells me we're going to go down 5. Okay? So there's our success criteria. Okay? We got to state these transformations. Now, here's the hard part. What does these do to our y? And we talked about this, but we're going to put this together. So vertical stretch, that multiplies by 3. So we're going to have 3y, right, down 5. That tells us that's the things that are doing vertical. Okay. The horizontal part is we have a compression of 2. So when we do a compression of 2, it's like taking x and dividing by 2. So what we're going to do is write down x divided by 2, and write 4 means we add 4. So this is going to be the tricky part. All right? Anytime we have a compression of 2, we divide, and we're writing right 4, we would add that. So how do we apply it? Well, what I would do is probably start at the easiest point. This is the easiest point to transfer. Think of it like that as my vertex of a parabola, right? This is my vertex, that point. So we know if we put 0, 0 in there, well, that, if I put 0 divided by 2 is 0, plus 4 is 4. That one, 0, 0 times 3, 0, minus 5. So I know that starting point has shifted right 4, down 5. So there's my point there. Now, we also know that this guy is symmetrical, so whatever happens to the right of our vertex of that point, it's going to match on the right side. So really, we only need to do the first couple here. All right? So now I'm going to put 1 in there. 1 divided by 2 is a half, plus 4, that's 4.5. And then 1 times 3 is 3. 3 minus 5 is negative 2. So I know that at 4.5, we would be at negative 2. And likewise, if we do it the same symmetrical, that's what we have. So they are symmetrical on both sides, just like the parabola will be symmetrical on both sides. Now let's put 2 in here. 2 divided by 2 is 1, plus 4 is 5. 2 times 3 is 6, minus 1 is, minus 5 is 1. So my next point would be at 5, 1. And likewise, this is symmetrical there. After that, we can just sketch the line. Because we know that this pattern is going to go up, like so. Okay. So if I was going back here, this would be 3.5 and negative 2. This would be 3 and 1. I've sketched my graph. All right, so start at the easiest point. So in terms of this would be my vertex, 0, 0. Transform that to that, and then pick the easiest points to transform. All right, so it made sense easy for the positive direction, and the negatives, this going to the left, it's the same side on both sides. All right. At any time, feel free to pause. All right. Here, my parent function is square root of x, because it's got a square root. All right. So I know that my points for the square root is 1, 4, 9, 16, 0, 1, 2, 3, 4. It's like the inverse of the quadratic. And let's list the transformations. Here, I got a vertical stretch of 4. And we have a reflection, because it's negative, so that's going to open down. We have a horizontal compression of 1/2, and we're going to come back to that in a second. And since the k is already factored out, we don't have to worry about factoring out k. It's bound up by brackets, so we're going to go left 8 and then up 7. All right. So here's the hard part. What are we doing to, we have to think about what are we doing to y first. So this is multiplying by y, and this one's multiplying, they're adding to y. So, and I'm going to make this a negative because of the reflection. So that would be negative 4y plus 7. Stretching is multiplying, that's adding. Now, compression of 2, 1/2, that doesn't sound very good. So if we were dividing by a fraction, we would do the reciprocal. So this is like almost saying this is a stretch of 2 horizontally. So that would be 2x, and left 8 means we subtract 8. Should have did that green. this should be 2x minus 8. So the hard part is picking out which transformations are happening to the x direction, left, right, and what's happening to our up, down transformations. Then we start at the easiest point. 0, 0 is the easiest point to start at. All right, 0, 0, that means I have negative 8 and 7. Actually, we probably should have plotted this first. All right, so there's my base function, y equals square root of x. And then now I can plot my point, negative 8, so negative 8, and then up to 7. There's my point. That's where this point has transformed to. Okay, now we're going to find the other points. We sub in 1 for x. So 2 times 1 is 2, minus 8, minus 6. And then 1 times negative 4 is negative 4, plus 7, that's 3. So I can plug that one in. Negative 6, 3 would be right there. And then I keep going. 4 into x, 4 times 2 is 8. Minus 8 is 0. 2 times negative 4 is negative 8 plus 1 plus 7 is negative 1. So my next point is at 0, negative 1. And so on. Let's do the 9. 9 times 2 is 18, minus 8 is 10. 4 times negative 4 is negative 16, plus 7 is 9. No, 3 times negative 4 is negative 12, plus 5 is 97. So I'm going to go 10, negative 5. So we way down here. All right, and then I can sketch it. All right, now I know that when I sketch it, it's that way. So here's some checks. Did I see you can kind of see that this thing shifted left 8, up 7. It was stretched by 4, so this went up 4 for every one of those. And it's actually twice as big this way. So instead of 1 this way, I went 2. Here I went 3, this would be 6. 5 is 10. And there's a reflection. So when we sketch these, we should see the transformations in our graphs that we make. So we should see the transformations in our image. All right. Now, do we have to list all these out? Not necessarily. If you see a pattern, that's fine. Just make sure that we hit our points. So this graph, this would be f of x here. Just like how this one was h of x. Okay. And that's it. That's the main idea of that. All right. So, we're going to try this one. So what I'm going to do is I'm going to hit pause, and I'm going to let you write down the transformations, and then we can compare our answers. So what you should have written down is a horizontal horizontal compression of 3. And we had to factor out that 3, just like we did when we were doing the trig graphs. We had to factor out that k. That's where I got the -2. That tells me what right 2, down 4. And when I have a compression of 3, we're dividing by 3, right 2, and then -4. So again, I would start off with my 0 point. So 0, 0 goes to 2, -4. If I put in 0 there for x, 0 there for y. If I put 1 in there, that would be 2 1/3. 1 minus 4 is -3. If I put that in there, 2 in for x, that would be 2 2/3. 2 minus 4 is -2. And maybe a question on this would make sense to do 1 more point. And that's okay. So 3 divided by 3 is 1, plus 2 is 3. All right, notice that it's the same number, it just happens to be 3 minus 4 is -1. So when you're sketching these, you can be selective. If I was looking at another key point, you probably realize here that this went down 1, this one went down 3. That's okay. That's where the 1/3 comes in. Okay. So do your best. 2, -4 would be here. The next logical point would be 3, -1. Well, if I looked at that, if I went up here, that would be 1 and -1. So just like our parent function, I'm going to sketch the parent function here. Okay. If I follow that same pattern, it should be a nice line. Okay, so this is h of x, my green line, and my blue line is my y equals absolute value of x. Okay, so you can be creative, that's fine, as long as you show me some thinking of how these transformations work. All right? Okay. The last one, again, I'm going to push pause, and then I'm going to let you try it on your own. So when you were looking at this, I'm going to zoom in a little bit so you can see it. All right, we had a vertical stretch of -2. All right, that's our A value. We went left 5, up 6. All right. And those were my parent function points. So the idea here, this one is y equals root x. All right. And then if I transform them, if I put 0, 0 in for x and y, I get -5 and 6. If I put 1 in for x, 1 minus 5 gets you -4. 1 times -2 is -2, plus 6 is 4, and so on. And then just sketch the graph. All right, so I sketched my parent function. -5, 6. All right. And then -4, 4. -1, 2. 4, 0. And 9, -2. So there's my f of x. And this is my parent function. So all I did was plot points. All right. All right. good luck, and we can take it up later.